This section is about tangents. A tangent is a circle that is a line or segment in the plane of a circle that intersects the circle in exactly one point. So what that means is down here, if you look at this circle, this orange line is a tangent because it intersects at this one point. Same with here. This line is a tangent because it intersects at that one point. So it's only touching at one point. That point of where it touches is called the point of tangency. A common tangent is a line that is shared between two circles. So down here is where you will identify where you have common tangents. Two theorems we may use. Theorem 1011, in a plane, a line is tangent to a circle if and only if it's perpendicular to a radius drawn to the point of tangency. If two segments from the same exterior point are tangent to a circle, then they are congruent. So down here, we have to identify how many tangent lines there are. So in this case, there would be 3 common tangents, so I would answer 3. Down here, you would have 4. 1, 2, 3, and 4. In example 2, you're trying to identify a tangent. So it tells you that AB is a radius of circle A. So you're determining whether BC is tangent. To do that, we're just going to use the Pythagorean theorem. So what we'll do is we will use this as our right angle at B. So we'll do 9 squared plus 12 squared, and then we'll set it equal to this hypotenuse. Now notice we're missing the length from A to the edge of the circle. This is still a radius of the circle. So since the radius over here was 9, this is also 9. So my hypotenuse will be equal to 15. So remember when we checked if it was a right triangle, we plug in our A, our B, and our C, and then we want to make sure that it gives you that same amount on both sides. So when we squared 9 plus 12 squared, we got 225. And when we did 15 squared, we got 225. So that makes this a right angle. Therefore, BC would be tangent. In example 3, it's asking you to use a tangent to find the missing values. So kind of going in the reverse of what we were just doing, we're going to use the fact that RQ is going to be perpendicular to QS since QS is a tangent. So we're still going to use the Pythagorean theorem, but now you're going to be using some more algebraic skills. So I'm going to be squaring x. So I have x squared plus 4 squared, but down here it's going to be x plus 2 quantity squared. So I remind you, when you were trying to multiply x plus 2 quantity squared, what you had to do was expand that out in order to multiply it. So x plus 2 quantity squared means I have 2 of these that I would have to multiply. So what we did was we split the x plus 2 in 2 different spots, and then we multiplied it to the second binomial. So you'll notice what I'm typing here is I'm splitting the x plus 2 down here on the side, and then I'm going to multiply to the x plus 2 that was the second binomial. So x times x right here would give me x to the second, and then x times 2 would just give me 2x. Now on the bottom, I'm going to do 2 times x, which would be 2x, plus 2 times 2, which is 4. So now we combine our like terms. So the only like terms you see are this 2x and this 2x. So I'm going to add those together. So you would get x to the second plus 4x plus 4. So remember, we want to split this x plus 2 down the side, and then that second binomial we'll just rewrite. So we distribute it to both and combine our like terms. So going back to our original problem, we have gotten x squared. We squared 4 and got 16. Then over here, when we expanded this out, we got x squared plus 4x plus 4. Now you're just going to start solving for that x. So we are going to subtract our x squared. So in doing that, those cancel. And then I'm going to subtract this 4 to the other side. So I would have 12 on the left side and then my 4x still on the right side. I'm going to divide by 4, and that would give me x equals 3. You're going to pause the video and see if you can do the check question. In the check question, you should be setting it up like this. So you should have x squared plus 14 squared equals 17 squared. When you start squaring and then subtract your 196, you should get 93, and then you will want to finish by doing the square root. So 9.64 should be your final answer. Okay, in example 4, we're going to use congruent tangents to find the measure. So we have a photographer wants to take a picture of a local fountain. She positions herself at a point A so that the fountain will be centered in the picture. AB and AC are tangent to the fountain. If the lengths of the tangents are given, find AB. Remember going back to that theorem that if they're coming from the same point, these two tangents end up being congruent. So we're just going to set them equal to each other and solve. 7x minus 9 equals 5x plus 5. You'll subtract 5, add 9, and then divide, and you'll get x equals 7. To find the length, you'll just finish by plugging in your 7. So 7 times 7 minus 9 would give you that 40. Pause the video and try the check question. In the check question, you should have set them equal to each other like you see here. I subtracted my 1x and added 3.5. After dividing, you should have gotten x equals 2. And then you just plug it into the DE. And so 3 times 2 minus 3.5 is 2.5. All right, now circumscribed angles. So a circumscribed angle is an angle that the sides that are tangent to a circle. So you'll see here that you have QSR being a circumscribed angle. If two segments or lines are tangent to a circle, then the circumscribed angle and the central angle that intercept the arc formed by the points of tangency are supplementary. So what they're saying is that P and S are going to add to 180 right here. A circumscribed polygon has vertices outside the circle and sides that are tangent. So here you see 3 examples of circumscribed polygons. So circumscribed means the outside, and then they're giving you examples that are not circumscribed. So what we're going to do in example 5 is they're showing you that you have 2 lines that are going to be tangent to the circle, and they're wanting you to find angle D. Well, we just got done saying that these 2 lines being tangent are going to make G and D supplementary. So I'm going to add 19x plus 9 plus 10x minus 3 and set it equal to 180 like you see here. Then I'm going to combine my like terms. So I have 29x plus 6 equals 180. Subtract 6, divide by 29, I get x equals 6. And then to finish, we're just going to plug it back in. So angle D was 10x minus 3. So I'm going to plug in 6 in there. Pause the video and try the check question. In the check question, you should have set it up similar to what I have here, where you add them and set it equal to 180. Combine like terms, subtract 15, divide by 11, x is 15. I feel like I'm just repeating myself. So you're going to plug in the 15 into the angle y. So you'll have 4 times 15 plus 5, and then you'll get 65. And then we have one more example, which is example 6. It's asking you to find the perimeter of this triangle. So if you have, remember, tangents that go to the exterior point, they're going to be congruent. So for example, if k to n is 7, then also k to m is 7. Same thing with down here. If jm is 14, then j to p is 14. And then if p to l is 11, then l to n is also 11. So you're just going to add up all those to find that perimeter. So that's what this is showing you down here. So I would just add 14 plus 14 plus 7 plus 7 plus 11 plus 11 plus 14. So just add them all up and you should be getting 64. Pause the video and try the last check question. On this last question, you'll notice that I added up all of my sides. So I went ahead and labeled them. And then to start my equation, I started down here on the bottom. So I added 3 plus 3, which is 6, put together my x plus 3 right here, then added my 2 x's. So I got 2x, then added my x plus 3 and received this, and then set it equal to my total. After that, it's just solving. So combined your like terms, so 4x plus 12, divided by 4, and then you get 1.5 for what x equals. So a little bit different than the last one. So this concludes our lesson about tangents.